Welcome to Pre-Calculus. Today we will investigate solving real-life problems using power equations, focusing on how evaluating given a certain domain value or solving given a certain range value compare as different math processes. Let's take a look at our first example. The weight in kilograms of a sea otter can be estimated by the function f of x equals 1.21 x to the power of 3/4, where x represents the otter's age in months. Determine the sea otter's weight at 2 years of age rounded to the nearest thousandth. So what we need to decide first of all is that given this function f of x, let's go ahead and write it out, equals 1.21 x to the power of 3/4. Whether I have in my information in the paragraph a certain x value, a domain value, or if I have a certain y value. So before I even start looking to plug in numbers for one of my two variables, I need to decide what those variables represent. So I see here in the words, we're told that x represents the otter's age in months. So I'm just going to label here x is age, and we're told the units there need to be months. The function itself is the way this question starts. The weight of a sea otter is f of x. So I'm going to put the f of x would represent the weight, and our units there are going to be kilograms. Now let's take a look at the actual data that we're given. We're saying determine the sea otter's weight. So that weight, again, remember, is f of x at 2 years of age. So if I look at that 2 years of age and just ask what kind of a measurement is that, that's a time measurement, that's age, so that's my x. But notice I have given 2 years, whereas in my equation I'm told that that x represents age in months. So as a first step, I want to convert 2 years over to months. So if we think, how would we make that conversion? We're going to take the 2, and we need to decide, should I multiply or should I divide by 12? So let's think, if I'm talking about a year and I want to move to a month, should the number go up or down? Well, in 1 year there's 12 months, so the number should go up. So when I'm picking between multiply or divide between those two operations, the one that's going to increase the number is the multiply. So I'm going to multiply 2 times, and I won't divide. So 2 times 12 will give me 24 months. And that really helps me see clearly what I need to substitute. So the number 24 and where I need to substitute it, it goes in for x. So what I'm calculating is really 1.21 times, and then I'm substituting in there from the data in the question 24 months to the power of 3/4. And what I'm looking for is a given weight. So notice how I'm substituting a single number, and then I'm looking to see how do I come up with that other measurement. In this case, how do I come up with the weight? So in terms of thinking, do I need to just evaluate or should I solve? Here I just need to evaluate, because everything in terms of my numbers is on the right-hand side. The left-hand side is a blank. I just need to calculate what's 1.21 times 24 to the power of 3/4. So that's a good setup, and we're ready to use our graphing calculator to evaluate there. So let's head over to Desmos real briefly. We just need to make our calculations. So here in Desmos, again, we don't have to solve anything. I just need to type in 1.21 times parentheses the base 24 months to the power of 3 divided by 4. So notice that it is a power function because I've got that x base raised to some rational number power. And that immediately gives me this irrational number, and I can tell it's irrational because it goes forever, the decimal doesn't end, and none of those numbers repeat. So I'm going to round to the nearest thousandth. So I'm going to record some values. I'll go up to 120,301. That's more than we need. And then we can decide what should we do in terms of rounding. So head back to our notes. And we'll just record what we saw there. So that was on this far left side, we'll put it in purple, 13 point. I'm going to write them all, and then we just decide where we should cut it off. 120,301. So if I look here in the question, it says round it to the nearest thousandth. And in terms of decimals, that's 3 decimal places. Remember, the first one's the 10th, the second one is the 100th, and the third one would be the 1000th. So I want to take this out to the 1, that's the 10th, the 2 is in the 100th, the 0 is in the 1000th, and I can cut off the 301. So the way that I would record my answer in the final form is 13.120. And then in terms of a number, that's correct if I were to include the units kilograms. So I want to be real careful here with how we're rounding, since we're told in the question, round to the nearest thousandth. So that's an example where we input a domain value and just evaluate to get a certain range value. Let's take a look at a different type example. So our second example starts by describing the free fall speed of an object on Jupiter in terms of distance measured in meters can be modeled by the function s of d equals 7 times d to the power of 1/2. If the free fall speed is measured at 70 meters per second, approximately how far has the object fallen on Jupiter? So let's notice what's similar here compared to our previous example. I do have, again, an equation or a function. So here I've got s of d equals 7d to the power of 1/2. And then I've been given some measurement, and I want to input that either for the domain, the d value, or the range, s of d, and then I want to come up with the other one that I'm leaving as a variable. Well, let's decide which is which. So again, I'll just write this larger, s of d, which is the free fall speed. So I'm going to start labeling. This is the speed. When I drop an object, and this is on Jupiter, so I drop my, I don't know, my car keys on Jupiter and they're falling down, that's their speed. The way I'd find the speed is multiply 7 times d to the power of 1/2, and that d, I'm told here, is really not given, except that I see this description here. It's the free fall speed in terms of distance, and that's meters. So what I'll label d as is that is distance in meters. And again, this is the same step we took for a first step in the previous question. We're just saying, what does my domain value, in this case d, what's it talking about in terms of the situation? And I always put the units there with it. The speed, we should put the units. That's going to be, we're given here some speed meters per second. And so we got, again, a connection between the equation and the real life situation, the real life scenario. So our domain values here are about distance measured in meters. Our range values are about speed measured in meters per second. So now I'm going to turn my attention to the actual question. It's saying, if the free fall speed is measured at 70 meters per second, approximately how far has the object fallen? So I'm just going to note that my number value here is 70 meters per second. And when I look at my two measurements, my domain is distance measured in meters. My range is speed measured in meters per second. So I see I need to make a substitution there for speed. And again, I see that because the units match. So let's make that substitution. So as I rewrite my equation here, I'm going to put the 70 for S of D equals 7, and then I'm going to leave that domain variable D in place. And it turns out that's what I'm wanting to solve for. I want to come up with the value for D. What is the distance when my object has fallen at a speed of 70 meters per second? So again, different from our first example, because that variable I'm replacing in this case is the range, S of D, the function value. So as I look at this and think, okay, how do I approach this to solve for D? I really have two things that are surrounding D. I have the power of half and I have a multiplication of 7. So in general, I want to try to get rid of any things that are added or multiplied before I take steps to get rid of any powers. So I'm going to try to get rid of that 7. So I see that it's multiplied times D to the power of half. So I'm going to get rid of it or cancel it by dividing. 7 divided by 7 is 1. I need to repeat that operation on the left side. So 70 divided by 7. We're in luck. That is an even 10. And notice what's left on the right-hand side is now just D to the power of 1/2. So now I'm ready to cancel that power. And I do see, again, this is a power function because it's a base to some rational number. And to cancel that power of half, I want to raise it to the power of the reciprocal. So I want to raise it to the flip of 1/2. Well, that's really raising to the power of 2/1, or simply 2. And what that will do, from our rules for exponents, I just multiply those, and that's half times 2. The way that cancels, it becomes 1. I do need to raise the other side, the left 10, to a power of 2 as well. And that solves this question for us. When I raise 10 to the second power, that's 100. And I see that that now equals just D. Now I've left a space there because I want to say what's my unit. Well, that's a D value. So again, I just look here at how I've labeled D is distance measured in meters. And so I do want to attach it back to that real life scenario in the final answer to say, okay, what I've solved for is an object that has fallen 100 meters on Jupiter is now traveling at a speed of 70 meters per second. Well, thanks for joining for this investigation of solving real life scenarios using power equations. I'll let you solve your own real life scenarios. Thank you for joining. See you soon.